Okay, so this is the last section in chapter 5. We're doing 5.5 and more inequalities than what we've already done. So our objectives today, we're going to use the triangle inequality theorem. And these are kind of fun theorems to determine whether 3 segments of a given length form a triangle. Then we're going to find the range of lengths for the third side of a triangle, given the lengths of the other 2 sides. So all these cool relationships between triangles. And then on 3, we're going to use the hinge theorem and its converse to compare the measures of sides and angles in 2 triangles having 2 pairs of congruent sides. So sounds like a lot of craziness. It kind of is, but they're actually pretty fun relationships that we're going to talk about. So first up, if the sum of 2 shorter sides is greater than the third side, a triangle can be formed. What on earth is that saying? Okay, so what's sum? Addition. Okay, so if we add the 2 shorter sides, and that's greater than the third side, so if we add side 1 plus side 2, and it's bigger than side 3, we can make a triangle. Okay, that means then we can make a triangle. If it's not bigger, then we cannot make a triangle. That's it. All right, so if I look at example 1, we just want to know, can a triangle be constructed with these side lengths? So we've got 9, 6, and 5. So we take 6 and 5, and we add them together. It has to be greater than 9. Well, what is 6 plus 5? 6 plus 11. So 11 is greater than 9, so yes, we can make a triangle. Okay, so how about B? How will we do B? What are my 2 shorter sides? 6 and 2. So 6 plus 2 has to be greater than 9 to make a triangle. It's 8, so 8 is not greater than 9, so can we make a triangle?
No.
No triangle.
Why can't you? Because it has those 2 smaller sides, so 6 and 2 are the 2 smaller sides. You have to add them up and it has to be bigger than 9, like the 11 on this side. And so it's 8, so it doesn't work out. And if it's not, it can't even triangle?
Can't make a triangle.
Like I picture it like I can draw like a 2 inches.
Open your book to page 234. Flip over 234. Because you can, and we'll show a diagram of why. I like it. So the reason why, let me go, right? So these are constructions. So if you were to use a construction and draw a 9-centimeter line, 6 and 5, you could, if you made those arcs, they would connect at this point. 6 and 2 would never connect. So if it's less than, they'll never connect to make a triangle. Now, here's the other thing. If they're the same length, which is the one we have next, what do you notice?
It's just a line.
It's just a straight line. Okay, if they're equal, they're called collinear. So that's what the C is there, because I cut out making the construction time. But yeah, so if we look at this one, 5 plus 4 is not equal to 9, or is not greater than 9, but 5 plus 4 equals 9. So in this case, we consider it collinear because they're equal. They'll be on the same line. The only time that they'll touch is on that line to make a straight line. So does that make sense to see the picture as well? Okay, perfect. Good. Any questions? I like it. So that's what the triangle inequality theorem says. Okay, that's exactly what it says. The sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. So, like you might write A plus B is greater than C. That is true for any triangle, ever, ever, ever. Right triangles have special qualities later on that we'll learn about. They have to have certain lengths to be a right triangle. Okay. So example 2, if 2 sides of a triangle have lengths of 4.7 centimeters and 6.8 centimeters. This one is like that objective. We said we're going to find the range of possible lengths. Okay, so that's what we're going to do here for that third side. So in order to find that range, we're going to add those two sides together. Okay, and say, well, that has to be greater than the third side, or these have to be greater than that third side. Okay, so if that's the case, x is less than 11.5. Then if we take 4.7 and add to x, okay, so that third side, x has to be greater than 2.1. Then if we take we switch and we say 6.8 plus x is greater than 4.7. What have I done to get all three of these separate equations or inequalities?
Added all of it with x.
Okay, so we had to have a third side, which was x. Okay, so they all have an x.
No, but you added them all like together and then like by themselves with x.
Okay, so I added the two sides together here. All right, to be greater than x. And then in the next one, we added one of the numbers with x to be greater than the other number. And the last one, we swapped them, right? We put the 6.8 with the x and said it was greater than 4.7. So yeah, we're adding the two sides together, and then we put each one with x and set it to the other one. How come this last one's crossed out? Right, we have x is greater than negative 2.1. It's not 2.1. It's x is greater than negative 2.1.
I thought it was an accidental marking.
It's not an accidental marking. It is crossed out. Why is it crossed out?
The triangle can't be negative, can it?
A what can't be negative? A triangle, that's true, can't be negative, but what are we? A side, right? We're finding the length here. So that's important as well. So it says, if two sides of the triangle have lengths of this, find the range of possible lengths. I cannot have a length of negative 2.1. So there's no way that's my answer. Okay, I can't have that length. So my possible length is my x has to be, if we write this the other way, has to be greater than 2.1, but it also has to be less than 11.5. So any number in there you can make a triangle with. Do we understand how we got to here from our problem? So if you had to do one, you could do it?
I struggled, yeah, because it's numbers.
You struggle because it's numbers. But this is the algebra part. Same thing? Okay. All right, then let's flip over to the back. Because we're kind of going to put this into action. All right, so a designer seeks to optimize kitchen efficiency by arranging the sink, refrigerator, and stove in a work triangle, quote unquote. The total distance between the three appliances cannot exceed 20 feet. With the stove to refrigerator distance being the shortest, explain whether each of the following sets of distances forms an efficient work triangle. If you would like a picture, you could turn to page 235. Okay, so there's kind of a picture there to help you understand that. All right.
Okay, that's a lot easier. I thought the appliances were in a triangle.
The appliances are in a triangle. Oh, you mean like they were a triangle sink? No. Gotcha. So yeah, we're trying to get this triangle shape. Okay, so the total distance for the three cannot exceed 20 feet. And then the stove to refrigerator distance being the shortest is the ideal. Okay, so will these work? Will they be an efficient work triangle? All right, so what's the total distance for the first one maybe? That would help us break it down. What's the total distance for the first one? We're adding, yeah, right? The sink to the, so S is the, stove. So we got stove to refrigerator here, refrigerator to the sink, and stove to the sink?
18.
So the total distance would be 18. All right? So if you just add those up to get that total. So check, it's less than 20, right? Cannot exceed 20 feet. That's good.
But the next one's 20.
The next one is 20. Okay, so 4 plus 6 plus 10 equals 20. But it said it can't exceed 20, so did we exceed it?
No.
No? Okay, so far we're good. We haven't exceeded 20. Okay. Let's actually jump over to, well, let's go ahead and look at it. The triangle inequality theorem. What did that say?
The sum of the lengths of any two sides of a triangle is greater than the length of the third side.
Okay. So the sum of any two lengths is greater than the third side. So how would we look at that for this first one, this 5, 7, 6?
5 plus 7. No, 5 plus 6 equals is greater than 7.
Okay, so 5 plus 6 should be greater than 7. What is 5 plus 6?
11.
So 11 is greater than 7.
Yep.
So are we good?
Yep.
Yeah, we're good. It meets the triangle inequality theorem. All right. How about the next one?
It's
4 plus
the
6 is
straight line though.
Do what?
It's 10. It's the 4 and 6 would be greater than 10, but equals 10.
Okay, so it should be greater than 10, but it's not, right? 10 is not greater than 10.
Is it that straight line then?
This is yeah, so this is that straight line. So these are actually set up in a straight line. Very nice. So these are collinear we would say points, but these are collinear appliances. In order for that to be the case, the stove has to be right next to the refrigerator, which is next to the sink. And so then the stove to the sink is 10 foot. Good call.
Shortest distance is 5.
So the shortest distance is 5. Okay. So is that help us, right? It says with the, so what I meant by that, let me go back up here, is with this work efficiency, I put that column in there because it says with the stove to refrigerator distance being the shortest. So you said this one is 5, that's the stove to refrigerator, so that checks out. And how about even for the other one?
Check.
It's a check, right? The stove to refrigerator is the shortest distance. So explain whether each set of the following will be form an efficient work triangle. What do we think? Okay, the top one will. And you could give those reasons, right?
Yep.
Like its total is 18 feet. It meets the qualifications for a triangle inequality, like to be a triangle, to actually form a triangle. And the shortest distance is from the sink or the stove to the refrigerator. And then the second one is a no, for the reasons that you guys found there. So very nice. All right, what are you like doling out all the candy back there? You the candy man today? I like it. Okay, so questions on that one? Does it make sense? Kind of like the, okay, because we're going to look at some other problems, or might be in your homework. I can't remember. Yeah, I think it's in your homework where you're doing a problem like this, but instead of it being a work efficiency triangle in the kitchen, it's like in an office, like the printer to the computer to some other piece of equipment. Same concept though. Yes, sir.
I'm just going to say this homework is going to be my last priority, so I might not get it done before Monday.
What?
Because I've got some stuff to do in Bible, health.
Are we not doing the next page?
And I still got to.
We are.
I'm
just.
still got to watch all the videos for the notes.
Okay. Okay, so now we've got two theorems, the hinge theorem and the converse of the hinge theorem. Okay, so the hinge theorem, if two sides of one triangle are congruent to two sides of a second triangle. All right, so we've got two triangles. All right, let's see, two triangles. And they said if two sides are congruent, right? Two sides of one triangle are congruent to two sides of a second triangle. And the included angle, okay, so now we're getting into this new part, and the included angle of the first is larger than the included angle of the second. that make sense? So the included angle of the first, see mine look identical, but this would be my included angle. Okay, so let's say this is 6, that looks like it's bigger than 90 actually, so let's make it 106. Okay, so if the included angle of the first is larger than the included angle of the second, so let's say this one's 100. Just do we understand what it's saying so far? Then the third side of the first triangle is longer than the third side of the second triangle. So this triangle is larger than this, or this angle is larger than this angle. Are we with me? Are you with me? Okay. The angle is always related to the opposite side length. So that means this side is longer, and the opposite of this angle is going to be shorter.
So bigger or smaller? Shorter or smaller?
Short, yeah, shorter or smaller. So we could say longer or smaller or whatever. I mean, it's not a lot of difference, right? Because it's 100 degrees versus 106 degrees, but it's just different enough that the side lengths are different. Does that make sense? Because if they're congruent, then it's all the same. So this is also called, can also be called the SAS side angle side inequality theorem, because we're looking at the side, the included angle, and the other side. So the converse, what's a converse do?
Flips it.
It flips it, so it's doing what?
The opposite.
It's doing the opposite.
Oh, so like
So it's gonna be.
if the two hypotenuses are different lengths, then the angles are different measures.
Sometimes you would think that would be it, yes. Like to do it that way. This one actually is a weird converse because it's also kind of the converse of the side, side, side. Or they call it the side, side, side inequality. So let's look at it just to be sure. So if two sides of one triangle are congruent to two sides of a second triangle, all right, so we're doing that thing again. So, yeah, my angles look different. So I've got two sides that are congruent. Okay, and the third side of the first is longer than the third side, or than, yeah, of the second. So now our sides, these sides are different lengths. Right, so this one's longer, isn't it? Okay. These are never drawn to scale, right? So this is the longer side, this is the smaller side. Okay, so the side that is longer, all right, then the angle opposite that third side is what? If this is longer, what do you know about this angle in comparison to this angle? If this is the longer side, the angle is going to be larger. So this angle is going to be smaller. So in the hinge theorem, we go from the angle to the side length. In the converse, we go from the side length to the angle. Does that make sense? So it's just a matter of like, which relationship do we know? And trying to find those relationships. All right, so then we've got some examples on the next page. So let's try those. Example 4, it says, compare the given measures, then name the theorem that justifies your answer.
This is the proof I did yesterday.
It was a similar one. You had to it was the same shape, but you had to prove something else about it. Yeah, right? Good call. All right, so we want to compare. What's the measure of angle KNL, so this angle, with the measure of angle MLN, so this angle up here. Or maybe I should name them 1 and 2. Let's do that. So we'll name them angle 1 and angle 2. So we can talk about them a little easier. So here is what we know. We know Kn is congruent to ML, because that's marked. And we know NL here is congruent to NL. All right. But KL is less than NM. Angle KL is less than.
Yeah, it should be line.
Okay, right. I was like, wait a minute, that doesn't make sense. Okay, yeah, because it's the length of KL. Oh, because they're numbered, right? KL is 5 and NM is 7. So 5 is less than 7. So I've just stated all the things that we know. Like we can, all the conclusions we can make. So KNL has to be less than angle MLN. How? Like why? Because the side's not as long, right? This side is opposite of this angle. And this side is opposite of this angle. This side is bigger, so we know this angle is larger. So angle 2 is larger, so we know this is less than. Is that clear as mud? Nope. So why is it the converse? Huh? Because we already know the side. The converse went from the side and told us something about the angle. We knew the side and we could deduce, pardon me, something about the angle measurement. The hinge theorem, it goes the other way. We know something about the angle measure, so we can make a conclusion about the side length. All right. So if we look at B, we've got UV in comparison to VW. So we know, again, like we're looking at what we know. UX here is congruent to WX. We know those are congruent. VX is congruent to VX. Okay, that's that reflexive property. But we know angle UXV, so UXV, that 58-degree angle, is greater than the measure of angle WXV, which is 37 degrees. So we know UV is bigger, right? UV is across from this angle. This angle is bigger, so UV is bigger. But why is that? What theorem justifies that? Why is this one the hinge?
Because it goes from an angle to the side.
Excellent. It's the hinge because it starts at the angle, what we know about the angle, and tells us something about the side. Perfect. Very good. All right. Questions so far? Do we need another example? Good? Okay. Then let's look at the last one. We want to find the possible ranges for x. All right, so I've got it kind of worked out there so we can see. It says find the range of possible values for x. How on earth did we get this?
You took the longer.
So actually, don't start here. Like, let's start with the picture. And like, what were you gonna say? You took the longer what?
Like you took the sides.
Okay.
Like it says, because it says two congruent sides.
Okay, so this is the conclusion. So we're gonna look at the hinge theorem because we have the angle measures, right? That included angle. So we're gonna take that hinge theorem. Keep going.
Two congruent sides, so you took those. But then the 100, what's that little circle?
Degrees,
Yard,
but 100 degrees.
is bigger, so it says the 3x minus 1 is bigger than the 5 minus x.
Okay. So, right, this one is bigger, so we know, because this angle is bigger, we know this side has to be greater than, that 3x plus 1 has to be greater than this side. Does that make sense so far?
Yep.
Okay, so that's where our inequality over here came from. So that's what brought us to here. 3x minus 1 is greater than 5 minus x. So we solved that. We got this x is greater than 3 halves. So what's that mean?
X is greater than 1/2.
But x
X
it has to be bigger than that.
has to be bigger than that. Okay, so it has to be bigger than 1.5. But it says find a range. 1.5 is not a range. So at what point, how do we know the next, like the range? Huh?
2.
2. Why is it 2?
Because that's the closest whole number.
It's the closest whole number. That actually is not it.
1.
What was it?
1.
1? Not 1. Okay.
Three?
So, because we have x is greater than 3 halves, okay, so that's one side length. So that would be our shortest length, right? Probably. So that's the longest we can do. But we also, it says, but must also realize the short side has to be greater than 0, right? We can't have a side that's 0, otherwise we wouldn't have a triangle. Are you with me? So the shortest side, the shortest it can be is 1.5 because x has to be greater than that. So this has to be less than x, right? But we need, for a range, do you remember from Algebra 2, you had to have like this compound conjunction? It could be anywhere from here to here. Sorry, not Algebra 2, Algebra 1. Like we're just studying this in my Algebra 1 class even. But you remember how you have to have that range of things? Okay, so in order to get that range, we need the upper value. So we can say, well, the short side has to be greater than 0. So the short side is 5 minus x, so that has to be greater than 0. When we solve for that, we get that 5 is greater than x, or if we want to put it the other way, x is, how would I rewrite this with the x first? Okay, x is less than 5, which finishes out what we need. So x, that range, is between 1.5 and 5. It has to be at least 1.5 to make a triangle. If it's more than 5, then it won't make a triangle anymore. At that point, it's not the shortest side. One of the other sides is the shortest. Does that, like it shifts. If it's over 5, then one of the other sides becomes the shortest, and it wouldn't make a triangle anymore. Do we kind of get that? Huh? Okay, so then let's get started on the homework. Because the theorem, like I said, they're kind of cool theorems to think about, but this is probably the hardest part, is finding the range of the lengths and how to do that. So I expect questions on Monday for those.